The definition of a sampling distribution is a collection of outcomes calculated with all possible samples of a certain size. Let's imagine that this is showing the heights of all Cal State East Bay students. So on the left side right here, we're looking at the distribution of the heights of all Cal State East Bay students in the student population. These are all the students who were 60 inches tall. These are all the students who were 65 inches tall, and these are all the students who were 55 inches tall. And we're imagining that the mean height, or the average height, of the Cal State East Bay population is 60 inches. So we're imagining that if we added everyone's height in the population and divided by the number of population members, the population mean would come out to 60 inches. Now, let's imagine that I select 4 Cal State East Bay students and I record their heights. And let's also imagine that I get one student who's 60 inches tall, right here. I get one student who's 62 inches tall. I get one student who's 64 inches tall. And I get one student who's 66 inches tall. So this right here is my sample of 4 people that I've selected. I've selected these 4 people and I've recorded their heights. Now I calculate the mean height of my sample. I add the 4 heights that I've recorded and I divide the total by 4. If I did that, the mean of my sample would come out to 63. The mean of these 4 heights is 63. And the mean of my sample right here would be one value under this sampling distribution over here. So here's an X. This sampling distribution includes the means of all possible samples of 4 people that I could have selected from the population. So now let's imagine that I take a different sample of 4 people and record their heights. This time, I get one student who's 69 inches tall. I get one student who's 70 inches tall. I get one student who's 72 inches tall. And one student who's 75 inches tall, way out here. So this is my second sample of 4 people that I've selected from the population. I've now selected these 4 people and I've recorded their heights. If I calculated the mean of this sample, if I added their 4 heights and divided by 4, I would get 71.5, because this is a taller group of people than this group of people. So it's 71.5. This right here was the mean of one possible sample of 4 people that could be selected from the Cal State population. Because this X right here was the mean of this group of 4 people. Right here we have a different possible sample of 4 students. So the mean of this sample will be a different X under the sampling distribution. So this, the mean of this sample will be right here. They have a mean of 71.5. So right here we have the mean of one possible sample of 4 people, which is this sample right here. And right here we have the mean of a different possible sample of 4 people, which is this sample right here. Now what if I selected a third sample of 4 students, recorded their heights, and calculated the mean, and this third group of people had a mean of 63. That group of people would have a sample mean that also equals 63, so their X would be right here. So this X is the mean of one group of people who have a mean of 63, and this X is the mean of another group of 4 people who have a mean of 63. And so these are the means of 2 different groups of people. It just happens that those 2 groups of people both have a mean height of 63. Now, what if I selected 4 students from the population and they had a mean height of 50 inches? If their mean came out to 50, they would be out in the left tail of the sampling distribution. So now we're looking at the means of 4 different groups of Cal State students. One of them has a mean of 50, one of them has a mean of 71, and 2 of them have means of 63. So this is just a shorter group of 4 people. This is a taller group of 4 people, and these are 2 groups of people who fall more in the middle because they both have a mean height of 63. Now if I selected 4 people from the population and those 4 people had a mean height of 60, then their X would be right here. In that case, I would have selected a sample with a sample mean that equals the population mean. In other words, the mean of my sample would be lining up perfectly with the population mean. And that sample would be right here at 60. And the reason why the curve is right here is taller in the middle and shorter in the tails is because most of the possible groups of 4 people will have sample means near the population mean. If I took a bunch of different samples of 4 people over and over again and calculated the mean of each one, most of the sample means would be in this area near the population mean. So there's a lot of samples in this area right here. And if I selected lots of different samples of 4 people and calculated the mean of each one, fewer of those samples would end up having really low averages. So that's why the tail is shorter here. And also not very many of those samples would have really high averages, which is why the tail is more narrow out here, or shorter out here. So basically, the reason why the curve is taller in the middle is because There's a lot of possible samples out there that have sample means near the population mean. There are fewer possible samples out there that have really low averages, and there are fewer possible samples out there that have really high averages. That's why the sampling distribution follows this normal curve right here. Now, in the next video, we'll talk about how the sampling distribution doesn't always have a normal curve. The shape actually depends on a couple of things. And one last thing I wanted to mention is that if I'm taking a sample of Cal State East Bay students and I'm recording their heights and I'm calculating the mean of my sample, the sampling distribution over here only exists as an abstract idea. It's not actually something that I'm actually constructing. The sampling distribution only exists in theory. But what's important is for me to be able to predict what shape the sampling distribution would follow if it were created. Meaning, when I'm taking a sample from a population and I'm calculating the mean of my selected sample, I have to be able to know what shape the sampling distribution would follow if I did actually calculate the mean of each possible sample and constructed the sampling distribution.